Welcome to qnawire.
So in this problem, we are supposed to estimate the wavelength of the X-ray emitted for a cobalt atom when an electron makes a transition from n is equal to 2 states to n prime is equal to 1 state. So we use the formula given in example 6, which is basically 1 over lambda, this whole equation. And the reason that we have instead of z minus 1 is because the electron in the 2s orbit, so let's say that this is the nucleus, this black dot, and this is the 1s orbit, and this is the 2s orbit. So for an electron to make a transition from n is equal to 2 to n is equal to 1, it basically sees uh, this the nuclear charge is shielded by one electron. So this outer electron basically sees z minus 1 charge instead of z charge. So that's why we have here z minus 1. So in this case, we just plug in the values. So let's move on to the next page. We basically plug in all of the values and calculate the value for lambda. So 1 over lambda. I'm not going to write everything because these are just constant. Uh, so the term in front of z minus 1 square basically evaluates to 1.097 10 to the power 7 1 over meter, and we have been given the atomic number of cobalt as 27, and the final state is 1s state, and the initial state is 2s state. So this basically evaluates to 5.562 times 10 to the power 9, 1 over meter. So when we invert this, so this is basically 1 over lambda. So when we invert this, 5.562 times 10 to the power plus 9 meters, it gives us 1.798 times 10 to the power minus 10 meters.